Okay, so now that we have defined quadratic equations as equations with a degree of 2, meaning that the highest exponent in the problem is a 2, let's talk about the general form of an equation. Just like with linear equations, the general form is like y equals mx plus b. Quadratic equations, general form is ax squared plus bx plus c equals, we could say, 0 or y here. Since we're going to be solving equations with one variable today, we're just going to talk about it being equal to 0. Now, sometimes you have an a term and a b term. Sometimes you have an a term, a b term, and a c term. And sometimes you have an a term and a c term. What you always have in a quadratic equation is an a term. The a term is always the coefficient of x squared. So whatever the a is the coefficient of x squared. Whatever the coefficient of x is called your b term, and whatever your constant is called your c term. So an equation that has all three terms might look something like 2x squared plus 4x plus 8 equals 0. So in this particular example, the value of a would be 2, the value of b would be 4, the value of c would be 8. This is a quadratic equation that has a, b, and c terms. If I look down below, if I have ax squared plus bx equals 0, this would be an example of an equation that has no c term, or no c term. So I could say 2x squared minus 3x equals 0. In this case, the value of a, the coefficient of x would be, or x squared would be 2. The value of b would be the coefficient of x, which is negative 3. And the value of c is equal to 0. Now, if I were to solve these two equations are examples of equations that cannot be solved by isolating the variable. So these equations right here, we will not be solving today. We will be solving those later. So these you need to solve using factoring or the quadratic equation, which you are going to learn in the very near future. Today we're going to focus on solving equations that don't have a b term. So for example, ax squared plus c equals 0. So suppose I have a problem like 3x squared plus 1 equals 0. Here, the a term is 3. The b term, because we don't have 1, we would say is 0. The c term would be 1. Because we don't have a b term, which would be the x term, this problem can be solved by isolating the variable. I would just subtract 1, divide by 3, and find the square root of both sides. So that problem can be solved by isolating. The next example, ax squared equals 0, that doesn't have a b or c term. So I could just have a problem that says something like 4x squared equals 0. Here, the a term, which is the coefficient of x squared, is 4. There's not an x term, so the coefficient of x would be 0. And there's not a constant, so the constant would be 0. These two types of problems we can indeed solve by isolating. So here we can solve by isolating the variable. And that's what we're going to focus on today. We've done a few of these already, but we're going to start getting into square roots. This is also sometimes referred to as the square roots method, which you'll see in the title of the paper. So let's try some out. So basically with these problems, the first thing we're going to determine is, can I solve these by isolating the variable? So you're going to start by just saying, what terms do I have here? Do I have an a term, a b term, and a c term? Now you might notice that they're not all equal to 0. It's fine. You can imagine if I got them all equal to 0, you would just move an equation to a term to the other side of the equal sign to make it equal to 0. So if you have an x squared term, you have an a term. If you have a x term, you have a b term. And if you have a constant other than 0, you have a c term. Okay, so looking at A, if I asked you what terms do I have, well, because I have an x squared, that's the a term, and because I have negative 9, that's the c term. So because I only have an A and a C, because I have no B term, no X in the problem, I can solve this quadratic equation by isolating the variable, which you should already know how to do. You're going to add 9 to both sides. The 9's cancel out, and you're left with x squared equals 9. And then to get the x alone, you undo squaring the variable by square rooting the both sides of the equal sign. The square root of x is x, and the square root of 9 is 3, but you have to remember there are two solutions, plus or minus 3. Remember, whenever you find the square root of both sides of an equal sign, there are two solutions, because 3 squared is equal to 9, and negative 3 squared is also equal to 9. So you have to account for both of them. So the answer to this is plus or minus 3. Now, question B. Question B, if you look, we do have an x squared term. Now, if I wanted to move the 40 to the other side of the equation to make it equal to 0, then you would have a minus 40, and that would be a C term. We're not necessarily going to need to do that for this problem. Just if you have a constant, if you have an x squared term, you know what terms you have. This is your A term, this is your C term, okay? So we do have an A term and we do have a C term. Because we do not have a B term, I can isolate the variable. So to get the variable alone, you just undo multiplication. So you divide both sides by 5, and you get x squared equals 8. Now, x squared equals 8, you might automatically be like, wait a second, I don't know how to find the square root of 8. But you do. You know how to simplify that, right? So we now find the square root of both sides of the equal sign, and the square root of x squared is x. You have to remember that I'm going to have plus or minus. The second you find the square root of both sides of an equation, go ahead and write x equals plus or minus. Now, the square root of 8, remember, you have to simplify. So we have to go back to simplifying radicals, right? So think of a perfect square that goes into 8. Well, that would be 4, right? So we could break the square root of 8 into the square root of 4 times the square root of 2. And remember, the square root of 4 is equal to 2. So this simplifies to x equals plus or minus 2 square root of 2. Now let's take a look at letter C. So if you look, letter C has an x squared term, it has an x term, and it has a constant of 9. So this problem has an A, a B, and a C term. So because this problem has an A, a B, and a C term, we cannot solve using isolating. So we cannot isolate. So we're not going to solve this equation today. We're going to learn how to solve this equation tomorrow. So now looking at the next row, stop the video and try D, E, and F. Tell me, do I have an A, B, or C term? And remember, if I don't have a B term, you can solve it by isolating. If you do have a B term, you can't solve it today. So you just will leave that one blank. Stop the video, give it a try. So first check to make sure you got your A, B's, and your C's correct. Both E and F don't have a B term, so we can solve by isolating. Now, if you solved E correctly, you should have gotten that x is equal to plus or minus 2/5. And then letter F, you probably ran into a problem, and you should have noticed that this problem has no solution. So now let's talk about these two. So for E, if you're getting x squared alone, the first thing you need to do is cancel out the 25. So you're always going to isolate the x squared first, right? Some people want to take the square root first. You have to do that last. That's your very last step. So then I'm left with x squared equals the fraction 4/25. So now to get the x alone, you find the square root of both sides. Reminder, when you find the square root of a fraction, you find the square root of the top and the square root of the bottom. And then you get x equals, well, the square root of 4 is 2, and the square root of 25 is 5. So you get 2/5, which you have to remember, it's plus or minus 2/5, because positive 2/5 squared and negative 2/5 squared end up giving you 4/25. Now letter F, you might be like, well, wait, I simplified this one. But if you look, when you subtract 120 from both sides, because you're always going to get the x squared alone first, like you're just isolating, just like you'd be isolating a regular x, you get 6x squared equals negative 150. Then you're going to divide both sides by 6, and you get x squared equals negative 25. Some of you might be like, well, when I find the square root of both sides, isn't that plus or minus 5? And the answer to that is no, because think about it. If I'm asking you to find the square root of negative 25, is there a square root of a negative number? So positive 5 times positive 5 gives you positive 25, and negative 5 times negative 5 gives you positive 25. So you can't find the square root of a negative number. Since that is negative, that means you have no solution to this problem. You have no real solution to this problem. We do have an imaginary solution, and you'll get into imaginary numbers when you get into Algebra 2. Now let's go ahead and take a look at the next row. Stop the video, try G, H, and I, and see if you can fill in the blank, and then come back to me. So here are the answers for G, H, and I, and the fill in the blank. If you did not get one of these correct, stay tuned. I'll go over H and I. If you got everything correct, go ahead and fast forward the video until you get to example 1 on the next page. So if you got H incorrect, let's take a look at it. I'm going to do that right down here. To get x squared alone, you need to first isolate the x squared. So you're going to divide both sides by 4. And then you get 48 divided by 4 is 12. So you get x squared equals 12. Then you find the square root of both sides of the equal sign. Square root of x squared is x equals, since we're finding the square root, we have to say plus or minus. And then quick reminder, when you simplify the square root of 12, remember that's the same as the square root of 4 times 3. And the square root of 4 is 2. So you would get 2 on the outside, square root of 3 on the inside. So that's how I got plus or minus 2 square root of 3. Now for question I, 16x squared plus 100 equals 269. Well, you subtract 100 from both sides, and you get 16x squared equals 169. Then you divide both sides by 16. You leave that as a fraction. X squared equals 169 over 16. Then you find the square root of both sides. Remember, when you find the square root of a fraction, you find the square root of the top and the bottom. And then you get x equals plus or minus, because you found the square root. The square root of 169 is 13, and the square root of 16 is 4. Go ahead and try example number 1 completely on your own. This one you can solve just by isolating the variable. And go ahead and try the check, and then tune back in. So for this problem, you should have gotten x equals plus or minus 3. If I were walking around the room watching you do this, if you got x equals 3, I would have said half credit. Okay, you have to remember that there are 2 solutions, which unfortunately, when there are 2 solutions, there are 2 checks. Now, for this particular problem with my checks, if you notice, I did this whole check, I saw that it worked, and then I did this check. And then after I did the first step, I noticed that my second line is the same as my second line over here. So since I noticed that, then I know I'm just going to continue on to get the same thing. So I didn't actually finish this one. I just pointed arrows. That's acceptable to me. All right, let's take a look at the next problem. This particular problem you can also just solve by isolating. So go ahead and follow, simplify, collect, isolate, check until you get the answer, and then tune back in. You will likely need my help on the check for this. So if you solved the problem correctly, you should have gotten x equals plus or minus 5 square root of 2. I want to remind you that in this problem, you have variables on both sides of the equation. So after you distribute, this is what you get after you distribute, and then you combine like terms, right? You could write this as 120 minus 5x squared as well. You have to collect your variables at this point, right? So you have 2 choices. You can add the 5x squared to both sides, or you can add the 2x squared to both sides. I chose to add the 5x squared to both sides. to give me 3x squared minus 30 equals 120, just because I like to keep things positive. If you chose to add the 2x squared to both sides, instead of right here having 150 equals 3x squared, you would have negative 3x squared equals negative 150. In the end, you would still get that x squared is equal to 50, okay? The square root of 50, remember the perfect square that goes into 50 is 25. So 25 times 2, the square root of 25 is 5. Don't forget your plus or minus. Now, the check for this. Let's start first by just checking 5 square root of 2. And so the check for this is a little bit daunting, but don't let it freak you out. After step 1, everything is going to turn out nicely, all right? So I'm going to start first by plugging in wherever I see an x, I'm putting 5 square root of 2. Now, since I already have parentheses, when I write my parentheses, I'm going to write 5, and then I'm going to make it a bracket because I need to put 5 square root of 2 in parentheses because I'm squaring it. So inside my bracket, I'm going to have 15 minus, in parentheses, 5 square root of 2 squared, close your brackets, plus 45 equals negative 2, put a bracket, inside parentheses, we're going to do 5 square root of 2 squared plus 15. And then we're going to follow the order of operations. So the order of operations says we have to do what's inside parentheses first. So we're going to look inside those brackets. And inside those brackets, we have to square 5 square root of 2 first. Okay, now look at the bottom of your screen. Let's just think about this. If I'm doing 5 square root of 2 squared, doesn't that mean I'm doing 5 square root of 2 times 5 square root of 2? So think about that. The two 5's on the outside, 5 times 5 gives me 25. And then you do the square root of 2 times the square root of 2. That would give me the square root of 4. Remember, the square root of 4 is just 2. Or you could just remember the square root of 2 times the square root of 2 is just 2. So 25 times 2 is 50. Now, if you look over to the left-hand side, isn't that what we got right here? The value of x squared was 50. We're really just double checking to make sure 5 square root of 2 times 5 square root of 2 does indeed give us 50. Okay, so this part right here now is just the number 50, right? So now the check is going to look just like a normal check after that. So I'm going to have now 5 on the outside. I'm going to change my parentheses, my brackets to parentheses, and make it 15 minus 50 plus 45 equals 2, negative 2. And then in parentheses, the 5 square root of 2 squared is 50 plus 15. And now from here, your check is just a normal check. So do what's inside the parentheses first. 15 minus 50 gives me negative 35. So I'm going to have 5 times negative 35 plus 45 equals negative 2 times, do 50 plus 15 inside parentheses. That's 65, right? Remember, when you're doing a check, you're following PEMDAS. Then over on the left, multiply and then add. So 5 times negative 35 gives me negative 175. I'm going to add 45 to that. That's going to leave me with negative 130. Over here, negative 2 times 65 leaves me with negative 130. So your check does work out. Now, because there are two checks, we're going to do the same thing, okay? So now, to save us some space here, I just want you to think through. If I put negative inside here, let's just think about that. Negative 5 square root of 2 squared, well, that would be negative 5 square root of 2 times, look, you're looking down at the bottom of your screen, negative 5 square root of 2. Well, isn't negative 5 times negative 5 also positive 25? Doesn't negative 5 square root of 2 also give you 50? So let's think about this. If I go back up here and I look, if I make this negative, this would still give me 50. If I make this negative, this would still give me 50. So after the first line, the check is going to look exactly the same. If for some reason my check was not going to look exactly the same, I would have to show both checks. But what you can do, and I'll do this in red, for your check here, you can go ahead and write plus or minus? Since the positive and the negative end up giving me 50, I don't need to write this whole check out again. Now let's go ahead and look at example 3. Again, stop the video, give this one a try all by yourself. It does look like that there's an x squared and a 3x, but think about collecting variables and see what happens. You can solve this by isolating the variable. Okay, hopefully I didn't trick you on this one. You should have ended up with no solution. So quick reminder, you had to collect your variables at the very beginning, right? Collect your x's. And what happens is your x's completely cancel out. And since they cancel out, you are left with an equation that just has an a term. So isolate the variable, but you get x squared equals negative 12. And remember, you can't find the square root of a negative number, so there's no solution. And bonus, there's no check because there's no solution to the equation. Now, the rest is practice for you to do on your own. I did provide an answer key on the last page, so make sure that you're checking to make sure your answers are correct. With these practice problems, some of the equations are quadratic equations and some of the equations are linear equations, okay? So remember, linear equations are equations where the highest exponent is 1 and where you would just have an x, right? And you can isolate the variable and you just solve for x. If it's linear, remember linear equations just have one solution. We've been solving linear equations for quite a while. If it's quadratic, remember, quadratic equations have two solutions, so you have to remember that there are actually two answers. Now, looking at number 1, before you decide if it's quadratic or linear, start the problem, right? At first glance, we might look at this problem and say, oh, this is linear because I have x's across the board. I don't have an x squared. However, if I start this problem, if I distribute the 1/4 x, 1/4 x times x does give me 1/4 x squared. And then 1/4 x times 40 gives me 10x, and that equals 25 plus 10x. So when you distribute, you get an x squared. So because I have an x squared, this is quadratic, which means there's going to be two solutions, okay? So from here, I would subtract 10x from both sides to collect the x's, and the x's will go away. So go ahead and stop the video, try this problem, and come back and tune in to see if you got it correct, and then I'm going to let you move on by yourself. All right, so this quadratic equation, when you collected both sides, the 10x to both sides, they cancel out, and you're left with 1/4 x squared equals 25. Now, to cancel out multiplication of 1/4, you divide by 1/4 or multiply both sides by 4/1. So you could also just be like, I'm clearing the fraction, or I'm multiplying both sides by 4/1. So the 4's cancel out on the left. I'm left with x squared equals 100. Then you find the square root of both sides, and that's going to give you x equals plus or minus 10. Now, this particular problem, you have x equals 10, and you have x equals negative 10. Because when I plug 10 back into the original problem, 10 plus 40 is going to give me something different than negative 10 plus 40. So this is an example of a problem where you absolutely have to do both checks. Both checks will look different, but both sides of the equal sign should work out, okay? The answers and the answers to the problems and the answers to the check are on the last page. So once you complete these problems, check your answers as you're doing them to see if you've got them correct. Good luck. Let me know if you have any questions.